Okay, so the job market in 2025, it feels a bit tense, doesn't it? Especially, I think, if you're looking at data science roles.
Oh, definitely tense. You hear it all the time.
Yeah, companies are just
Yep.
swamped, right, buried under applications. But then you also have these, like, incredibly talented
People
candidates.
with PhDs, years of serious research.
Exactly. And they're just getting ghosted or, passed over completely. It feels, I don't know, overwhelmed on both sides.
It really does. It's a strange dynamic.
So let's paint a picture, maybe one that feels a bit too real for some listeners. Imagine you're a neuroscientist.
Okay.
You've spent, say, 8 years really deep in it, modeling complex brain systems, getting peer-reviewed papers out there, work that's stood up to serious scrutiny.
Right. Really rigorous stuff.
You have the analytical skills, the stat background, you know how to handle complex data, but then you apply for that industry data role,
Yeah.
and your application just vanishes. Filtered out by an algorithm, probably because your CV didn't have Jupyter Notebook listed explicitly.
Ugh. Yeah. That's that's painfully accurate for a lot of
It's
people.
disheartening,
Yeah.
right? Feeling like all that deep expertise just doesn't even register.
In that scenario, I think it really highlights this quiet but honestly glaring problem we have.
Yeah.
There's this disconnect
A disconnect between.
between what companies say they want, innovation, problem solving, and where they're actually looking for talent, or maybe how they're looking.
Right.
So the whole point of this deep dive today is basically this. If you're a scientist, that neuroscientist maybe, you already have the core stuff needed to kill it in industry.
You just need to tell the story differently.
Exactly. Reframe the story. And maybe, just maybe, companies need to adjust their lens a little too.
Absolutely. So, yeah, our mission here is to help you, the listener, really get that. If you're that scientist thinking about this jump, you are not starting from zero. You're just changing the label, maybe, switching context. See, the skills are there.
Fundamentally, yes. It's about translation.
Okay, let's dig into that. Why are companies missing out? What's happening on the hiring side that creates this barrier for really smart people?
Well, part of it, I think, is just how vague the term data scientist has become. It's kind of a mess, honestly.
How so?
I mean, it's this huge umbrella term now, right? It covers statistical modeling, sure, but also ML engineering, data architecture, business analytics. It's massive.
Okay, so it's poorly defined.
And that fuzziness, well, it makes hiring tricky. So recruiters, often under pressure, they fall back on what seems efficient.
Checklists.
Exactly. Checklist. Does the resume mention Python, AWS? Do they have a GitHub packed with side projects? Tick, tick, tick.
Seems logical on the surface, maybe.
Yeah, but it creates this massive blind spot. They're optimizing for keywords, not necessarily for, deep thinking ability.
So back to our neuroscientist example.
Right. This person, 8 years dealing with messy, real-world, multimodal data, designing careful experiments, applying serious statistical rigor, getting findings published against tough peer review.
That sounds like hardcore data work to me.
It is. One of the sources we looked at even calls it data warfare. They're not just cleaning neat spreadsheets. They're wrestling with ambiguity, noise, complexity, finding signal in chaos.
Which sounds exactly like what companies should want.
You'd think so. But if the resume doesn't shout Jupyter Notebook or SQL loud enough, poof, no callback, filtered out.
So it's definitely not a lack of skill. It sounds much more like a language problem, a perception gap.
That's it, exactly. It's a mismatched language. Companies are filtering out the very minds they probably need the most.
Minds that can handle what, exactly?
Minds trained to wrestle with ambiguity, to synthesize really complex information, to innovate when things aren't clear-cut, under constraints. These aren't skills you find by searching for Docker or Tableau on a CV.
Tools versus thinking.
Precisely. Tools can be learned, often quite quickly. That deep, critical, scientific thinking, that takes years to cultivate, often in places like academia.
So this blind spot you mentioned, focusing on tools over, let's say, intellectual flexibility, what does that do to the teams they end up building?
That's a great question. It leads to building teams that are maybe easy to manage on paper. Everyone has the same tool sets, makes the same immediate language.
But maybe not the team that will push boundaries.
Exactly. Playing it safe like that, only hiring people who look like the last person hired. It's actually a huge risk in itself. It breeds stagnation.
So how do you break that cycle?
You have to consciously hire people who don't fit the exact mold. Think about it. Maybe a psychologist joins the team.
Okay.
And suddenly they figure out why user engagement is stalling, because they see human behavior patterns others missed.
Or a physicist.
Yeah, a physicist might completely rethink an optimization engine using principles from a totally different field, something the existing team would never conceive of.
Or like a cognitive scientist.
They could uncover product insights that no dashboard, however sophisticated, will ever surface, because they understand how people actually process information. These are the potential game changers.
The unsung innovators.
That's a good way to put it. I actually saw this happen. A former theoretical physicist joined a finance firm.
Okay.
Totally revamped their risk assessment models using approaches from physics, stuff the standard quants hadn't considered, made it way more robust. That's the kind of impact we're talking about. Diverse scientific thinking.
Wow. Okay, that really challenges the standard idea of a good fit. So let's flip this now. Let's talk directly to the scientists, the researchers listening, because there's often this fear, right? This feeling of,
Imposter syndrome.
yeah, I'm not industry ready. I'm not technical enough. My skills are too academic, too niche. It's pervasive.
It really is. But here's the truth, and I really want this to land. You have been doing the work. You've been building complex models. You've been designing rigorous experiments. You've been crunching high-dimensional, often messy data. You've been writing code, maybe not always Python, maybe with R or MATLAB, but you coded. You communicated incredibly complex findings, often to very critical audiences.
Right, defending a thesis is no joke.
Exactly. You iterated, you debugged, you collaborated, you presented under pressure. You are doing data science. You just called it research or computational modeling or statistical analysis.
So you're saying the work is fundamentally the same, just the label is different?
And the context, yes. You've been operating within a different framework, often with fewer resources and maybe even more ambiguity than many industry roles face.
So the big hurdle isn't really learning entirely new skills from scratch. It's more about translation.
Translation is a huge part of it, yes. Changing the dialect, like we said, but also recognizing the core scientific method you've been using all along.
The scientific method itself.
That whole cycle, right.
Yeah.
Forming hypotheses, designing careful tests, analyzing results critically, questioning assumptions, iterating. That is data science at its best, regardless of the domain. You've been doing that for years.
Can we make that more concrete? How does specific academic work translate?
Okay, great idea. Let's take some examples. Say you built a complex pipeline to analyze EEG data, processing brain signals in real time. In industry terms, that's real-time data processing. That's signal analysis. Handling high-volume continuous data streams. Very valuable.
Yeah, what else?
Remember writing and defending that grant proposal, where you had to meticulously outline your research questions, your methods, your expected impact, and justify the budget to a skeptical panel.
Painfully well.
That's project scoping under uncertainty. That's stakeholder management. That's communicating technical plans and justifying value. Industry needs that constantly.
Okay, that makes sense. What about experimental design?
Huge. Your ability to design experiments to isolate causal factors, control for confounds, understand statistical power that maps directly onto A/B testing, product experimentation, marketing analysis in industry. It's the same core logic.
And the publication, the papers?
Every single peer-reviewed paper is basically a portfolio piece.
Sure.
It demonstrates reproducibility, methodological rigor, and crucially high-stakes stakeholder communication. You took complex findings and made them clear, defensible, and compelling for a critical audience. That's data storytelling.
Wow. Okay, laying it out like that. It's not just sort of related. These are core transferable skills.
Exactly. They are precisely what industry needs. It's just wrapped in academic language. The expertise is already there, deeply ingrained.
Okay, so for the listener who's thinking, all right, I buy it, I have these skills, what are the practical steps? How do you actually translate your story so industry gets it?
Right. Actionable advice. This is key. First step, your CV or resume needs a serious rewrite. Think impact, not just methods.
What does that mean practically?
Don't just list published paper on X or use statistical method Y. Focus on what problem you solved with that paper or what insight that method revealed. How did your work lead to something? Frame it in terms of outcomes and impact, connecting it, if possible, to goals businesses understand, like improving accuracy, finding efficiencies, uncovering new patterns.
So instead of analyze neuronal firing pattern,
Try something like analyze complex biological data sets to identify predictive patterns, resulting in a new model that improved prediction accuracy by 15%. See the difference? It highlights the outcome. Got it. Okay, what's next?
second, ditch the jargon. Consciously swap out overly academic or technical terms for phrasing that resonates more broadly in a business context.
Like the ANOVA example you mentioned earlier.
Exactly. Instead of repeated measures ANOVA, talk about analyzing longitudinal user data to identify key trends, or optimizing user experience over time based on behavioral analysis. Translate the purpose and result of the technique, not just the name of the technique itself.
Makes sense. Be understood by a wider audience.
Precisely. Third, explicitly call out your transferable skills. Don't assume they'll read between the lines of your publications.
Tell it out.
Yes. List things like coding proficiency. Mention the languages, sure, but focus on problem solving with code. Statistical modeling, data visualization, experimental design, and definitely data storytelling. And this is a big one. Emphasize your comfort with uncertainty, your ability to wrestle with ambiguity, dig for causality, and question assumptions. Frame that as a strength.
Because it absolutely is. It absolutely is, and it's rarer than you might think. Finally, while your papers are a portfolio, consider making some work more accessible in an industry format.
Meaning?
Maybe contribute to an open-source project relevant to your interests, or take a piece of your research code, clean it up, maybe apply it to a public data set, and put it on GitHub with good documentation.
Show, don't just tell, in their language.
Exactly. It gives recruiters and hiring managers something concrete and familiar to look at, demonstrating your practical skills directly.
That's all really solid advice, and it reinforces the idea that it's not about pretending to be someone else.
Not at all.
It's about learning to articulate the value you already possess in a way that the industry can recognize and appreciate, speaking their language without losing your scientific soul, so to speak.
Well said. You're translating, not changing your core identity.
So let's zoom out a bit as we wrap up. There is a fascinating idea here that in many data-heavy roles today, the missing ingredient isn't another tool or algorithm. It's science, the actual practice of scientific thinking. Many problems aren't really tooling problems. They're thinking problems.
I completely agree. Organizations are drowning in data, but often starving for insight. They need people who don't just run the numbers, but who ask why, who challenge the assumptions baked into the data or the request itself.
People trained to deal with the messiness.
Yes. The solution often isn't just a fancier dashboard or one more metric. It's bringing in people who are comfortable with that messy, uncertain reality of scientific discovery. People who instinctively dig for root causes, who question correlations, who design ways to test causality. That's the scientific mindset.
And we need them. Industry needs them.
Desperately, I'd argue, to move beyond just optimizing the status quo and towards genuine innovation.
So the message to you listening right now, if you're that scientist on the fence, seriously, take your shot.
Please do.
You need to internalize this. You are already ready. Your training, your rigor, that unique way you approach problems, it's incredibly valuable. Even if the job descriptions don't explicitly ask for it in those terms yet.
They might not know how to ask for it yet, but they need it.
Yeah.
And think about this. As the world gets even more data saturated, what's going to be the real differentiator for companies? It won't just be having more data or more tools.
It'll be the thinking.
It will be deeper, more rigorous scientific thinking, the ability to cut through the noise, find true signal, understand why things are happening, and make smarter decisions based on that understanding. That's where the competitive edge will be.
So the final thought for you to ponder is, how are you, with your scientific background, going to leverage that unique mindset? How will you help redefine what data science can actually achieve within an organization, moving beyond just the technical execution into that deeper, more impactful realm of scientific inquiry?
That's the real opportunity here. It's huge.
It really is. And hey, if you know a colleague, another scientist maybe who's wrestling with these same questions about moving from academia to industry, maybe share this deep dive with them. It might just be the encouragement they need to see their own value differently and make that leap.
Good call. Spread the word.